Thank you for that lovely, warm welcome, and to all of you as well for coming along to see my talk. So the title is Fun with Serverless JavaScript. I'm passionate about the serverless technologies. It's something that I'm using in my work and I'm really enjoying. I reckon I know just enough JavaScript to get away with JavaScript at a JavaScript conference, but try not to ask me any detailed questions about the JavaScript. This is not my first programming language. And because Nordic.js is a super cool event and I really, really wanted to come, I put fun in the title, hoping they would accept my talk. Only now they have, and I'm here. So to help me out with the fun, I've brought along a co-presenter. Now, I didn't anticipate how big this room would be, so you probably can't even see this. But and if you're watching on the live stream, you have no hope. On the table here is an Amazon Echo Dot, and she'll be helping with the fun side of things through the day, providing that the live demo works. They say never work with children or animals. I would add partly sentient electronic beings to that list. So she may or may not be on my side today. Let's see how we get on. Alexa, how are you?
I'm great. I hope you are too.
Feeling a little bit better, actually, thank you. So, let's talk about serverless. The first thing that I need to tell you is that serverless is a lie, because, in fact, there are servers. It's not serverless at all. It's the separation of worrying about hardware and virtualization and operating systems and worrying about code and doing those as two different things. The serverless revolution, you'll also hear this term, no ops. It's not no ops. It's the best ops you've ever seen. It's just that somebody else did it. The serverless revolution is arriving now because the ecosystem is ready for it. It's a natural progression from, if you are old enough in technology years, with no relation to your calendar age, then you'll remember once upon a time we bought actual servers and we rented space in other people's data centers and paid for power, connection, and things. And then we went to kind of virtual servers, and recently, at technical conferences, you have probably seen a lot of talks about containers, whether that's Vagrant or Docker or things. I am not an op. But all of those things, the containerization is what enables serverless. It's what allows us to have serverless as a technology, to simply focus on a single unit of code, to throw it in the cloud, and have it run and scale on demand. And that's what serverless is. And it's happening now because it couldn't have happened before. If you're not familiar with serverless, it can mean many things. Today I'm focusing mostly on functions as a service, but you'll also hear backend as a service. The idea of building your application mostly from third-party services, remote APIs. Whether you write those APIs or you using someone else's, doesn't really matter. The ideas are the same. So you're going to write a function, deploy it to the cloud. It's basically an API endpoint, although it can be triggered by things that are not HTTP requests. It scales up. As much as you trigger it, it just grows. And you only pay for the time it's running. So if you write something incredible but nobody uses it, it doesn't cost you anything. You don't have to run with your servers scaled up and ready. I think serverless is very approachable, especially to people who are already JavaScript native. Backend developers, you already write Node. This is just a different architecture for you. Front-end developers, you don't need to worry about setting up anything, installing stuff. You just write a function and you ship it. It's a very approachable way to add server-side functionality to the excellent client-side stuff that I know you are already doing. All of the serverless platforms support JavaScript as like a first-class language. They all do. Most of them only have good documentation for JavaScript, with some other languages that in theory are supported. This crowd is absolutely on the leading edge of this technology as it is adopted. So functions as a service, what we do is we think about what it is we're trying to achieve. What should the outputs be of our individual component? To achieve that, what should the inputs be? Then the easy part, you write the code to get from one to the other. Gonna skate over that because you know how that works. And like I say, you only pay for what you use. It's normally charged in units of gigabyte seconds. Spoiler, normally doesn't use a whole gig of RAM, usually doesn't run for a whole second. So there's a lot of 0.000 maths when you look at costing up a platform like this. And also, all of the serverless offerings will give you some large number of free invocations, so free function actions. So you can play with this and even deploy it on a small scale for no cost on any of the platforms. So it's a very approachable thing to play with and to get started. That said, there are definitely some good use cases and some situations where I have seen organizations deploy serverless because it's the new shiny. And we love shiny. We all love shiny. And then undeploy it, because actually it wasn't really a good way of doing stuff. Serverless can be more complicated because it's made of lots of small functions that you need to be able to source control and deploy. So here are my favorite use cases, the times that I would totally recommend. If you have a problem shaped a bit like this, serverless is worth your time to investigate. Very occasional server needs. If you have a mostly static website that occasionally sends data somewhere, you don't need a full-time running dynamic server for that. You can generate your static site, deploy it, and just have a form that submits to a serverless action that will then write to a database, send an email, whatever it was that you needed. If you have very, very variable traffic levels, this can be quite nice to add in, particularly if you have a lot of clients open and something can happen that makes them all phone home to the server at the same time. Having some good caching and a serverless endpoint for that can work really, really well, because otherwise you end up with a platform that is scaled up for your maximum expected traffic all the time. That's expensive. So for very bursty and unpredictable traffic, I have seen this used very effectively. And the classic example for serverless is to provide extra compute that you don't necessarily want on your web tier. You always hear image watermarking, thumbnails, right? That's actually a really good use case. If you can get that off your web tier into like a third-party API or something, that's good. Serverless allows you just to make it a first-party API, if that makes any sense. So you can write that yourself, but not make it part of the same application that's running on that web tier. There's a bunch of serverless platforms. So if you are already in the Amazon ecosystem, you are probably going to use Amazon Lambda. Amazon Lambda absolutely led the way in this space. And I think all of the other offerings have kind of followed along. I have both Amazon Lambda and IBM Cloud Functions, which is actually an installation of OpenWhisk. It's an open source project. I have both of those as examples to show you today. I use both platforms. Amazon Lambda, because everybody uses Amazon Lambda, and IBM Cloud Functions, partly because it's an open source project and I really like it, and also I work for IBM, they pay my hosting bills. So that makes them a compelling offering. Also, Twilio have an offering, Azure have an offering, there's Google Cloud Functions, Iron Functions looks really good if you're not already allied to one of these cloud platforms. So, now you are sold, let's look on how you actually do it. So this is like when you go back to your desk and you want to try it, this is what you're going to do. If you want to work with Lambda, then first of all you need to install a package called AWS CLI, and it will give you an AWS command, and that will let you start to manipulate the Lambda stuff. You need to set up some permissions and then apply them with AWS Configure. If you are Amazon native, you know what this means. If not, I had to get help with mine. You need permissions for Lambda, obviously. I'd also recommend that you add API gateway permissions and the cloud watch logs as well. That will give you everything that you need to effectively work with serverless, make web requests to hit your functions, and also debug it in the event that not everything works perfectly first time. Unlikely, I know, but it could happen. Write some code and then zip it. Now, you don't need to zip it in this example because I've got one JavaScript file, and you can ship one JavaScript file, and that will be fine. But I want to show you how my real dev cycle works when you get beyond Hello World. And once you start to add more than one JavaScript file, some dependencies which weren't available on the serverless platform, maybe you include package.json to get some config deployed, then you need to zip those things. So let's adopt that pattern from the start and zip it. So I've created hello.zip. To deploy this with Amazon Lambda, you're going to run this command, AWS, from the package that you just installed, Lambda, and then create function. Give the function a name, explain how to run it, apply the role that it should use, so that's back to the IAM permissions that I mentioned. Give it a description, try to write something meaningful, because after 3 or 4 experiments, your dashboard gets confusing. So write meaningful words here. The handler argument is the entry point for your code. So I'm exporting a handler function from index.js. So my handler is index.handler. And supply the zip file, it's a binary like this. Once you've created it once and you're now iterating, changing your code and re-uploading it, then there's a different command to use, and that is the update function code, just to ship new code. If you want to change the config, guess what? It's update function config. Okay, good. To run it, we're going to use the AWS Lambda command again, and this word invoke. So invoke meaning please run my action or function. Name of the function, and then you can supply the file name where you would like the output to go, and you have to supply a file name and it will output it. There's other ways to trigger Amazon Lambda, but from the command line it looks like this. And the code is well within the grasp of everybody here. This is Hello World in Amazon Lambda. So we've got a function that accepts event and context. And in simple terms, the event is the incoming parameters, what caused this thing to run. And the context is where we're going to indicate how things are going. You can see that I've got a succeed here. You can also do a fail. So that's kind of the objects that we will interact with. And you can see here that I'm just returning a string. When I run that invoke and it hits output.txt, that hello world string will be all that's in that file. The thing I love about serverless is it's just really approachable. Like you could all go to the office tomorrow or maybe whip out your laptop having lunch and do this. It's really achievable. The JavaScript, as you can see, for such a simple example, is unsurprisingly very simple. It does, however, differ slightly between the different platforms. So this is Amazon Lambda. Try not to blink. This is OpenWhisk, so IBM Cloud Functions or the open source version. It's very, very similar. I've called my function something different because main is just the default on OpenWhisk, and the function accepts just one argument. If you want to run your code on multiple serverless platforms, either for redundancy or because you haven't chosen a supplier yet, or you don't want to be locked in to one provider, which is, I think, something that's very valid, particularly with all these different sort of cloud-walled gardens, then you need to look at something called the Serverless framework. Have a link at the end of the slides, and if you check my Twitter account, then I've just tweeted that link, hopefully if I've worked buffer in the correct time zone. Use the serverless framework because that attempts to abstract these differences and will give you code that you can deploy to multiple different platforms successfully, which is awesome. So you've already seen the code. Let's look at the mechanics for OpenWhisk. We've got the Whisk WSK CLI tool, which is the open source version, also works with IBM Cloud Functions. If you're using other IBM Bluemix stuff, then you're probably already using the BX tool. It doesn't matter which. If you're using one, it's just WSK. If you're using the other one, it's BX WSK. I'm really confident that you can translate between the two without me showing both options. Again, I'm going to zip my JavaScript file and then deploy it. Although I'm deploying this for the first time, OpenWhisk allows me to use update, and it just assumes that I mean create if it wasn't there already. So my cycle time looks the same every time, which is nice. Say it's a Node app and give it a name. I'm using a package name as well as an action name. So demo is a package. OpenWhisk has this concept of packages. You can attach parameters to the package and actions, functions, inside that package. It helps to keep things together once you've got, once you get past sort of 10 or 15 packages, 10 or 15 functions, that list gets quite long. The packages are quite helpful to keep things together, so I use that extensively on OpenWhisk. Once we've deployed it, we can run it. Again, it's just whisk action, and the keyword is invoke, because run isn't shiny enough. And we need this dash blocking keyword when we work with OpenWhisk. And that just means, please wait and return me the result. Don't just ask it to run and then forget. All right? The dash blocking will keep that open until the function has run, and then you'll get the output on the console. With OpenWhisk, the output's fairly chatty. It's quite verbose, but there will be a result element in there somewhere. With OpenWhisk, you're going to return either an object or a promise. As soon as you return, your event loop is frozen. So if you've got async stuff, API calls, database calls, cache hits, anything like that, you need to return a promise and handle that async in that way. Something that seems to trip up people coming to OpenWhisk with good JavaScript experience for the first time. One nice thing about OpenWhisk is it has this ability to web enable. My code is so big, I can't find my way around. To web enable each action. So you can literally say, make this action open to the web, and then you get this pretty ugly URL where you can access it. It's like the Whisk endpoint, the account that you're using, the space that you're operating in, the package name, the action name, and so on. This doesn't need to be pretty if you're just using it as an endpoint for a Slack bot to webhook to, or a form post from a static site or something. This is everything that you need, and it allows anonymous access, which may or may not be what you want. There are API gateways, both on Amazon and on Bluemix, which will do much nicer routing and auth and everything, but if all you want to do is expose the thing you just made, this is the way to do it. And now I've kind of got into this realm of, let's write a function, let's put it in the cloud. Let's make a route that means we can hit it with a URL. And put those things together, and we've made microservices. And all those talks that you've heard about microservices, about designing microservices, about data hygiene, about only having one service responsible for each storage, the theory about passing data between microservices, having them talk to each other, all of that is reusable. Serverless and microservices, I speak on both topics, and there's a lot of crossover in these. So people moving to microservices architectures often adopt serverless. People moving to serverless architectures find themselves following those familiar microservices patterns. It is a buzzword, right? It's an API, but it's quite small. But I think it's a good one. I think it brings together two nice modern concepts, puts them together very neatly. So now I'd like to try to show you around a real project, still quite a basic one, that I worked on, which is a little bit more than Hello World. So this is the fun part. And for this, I need my friend whose name I can't say because then she talks back to me. Let's see how well that works out. So the Amazon Echo Dot, who shall not be named, if you don't, does anyone have one of these devices? A few. I don't think they're like massively out in Sweden yet. I did this in the UK and like half the room had one. So you get these devices and what they do is when you say their trigger word, they start to listen. They are definitely not streaming the audio from your house to Amazon's computers at all times. They definitely only listen when you say the trigger word. And don't read Hacker News this morning because there's a story about how you can get high frequency commands that we can't hear but they can hear and they respond. Oh my word. Okay, so skating over all of the scary privacy issues about the fact that I have 3 of these in my house, you speak, the device sends the sound to the cloud works out what to do. It's not quite as simple as speech to text command, but it works out what to do and it sends it back a response, which is also delivered in a voice sort of format. So you need a fairly formulaic way of addressing the device. So you say the trigger word, and then you invoke the skill that you want to use. So a skill is like an app for Amazon Echo. There's a marketplace. You can write your own skills. It's like it's the package name. So this is the invocation, the word that we say to choose that specific skill. So you say ask or tell, invocation, to or about, the intent, so that's a function. It's very shiny text, so we can't use any of the old words. We have to use new words. Intent meaning function. And then all of the other variables are slots. They're variables, but they're called slots. So your invocation will always look like this. There's also some really nice stuff in the Amazon Echo framework, which I don't have in today's demo, but I have worked with, where she can prompt you for these various slots. So if you have like a meeting planner app, you can say, plan me a meeting, and she'll be like, with whom? On what day? Should I book lunch with that? Like, she can ask you a bunch of questions to fill in the blanks and then do the thing, which is quite nice. So the example that I've brought you today is called Project Codename. Because if you're going to rush back to the office and start a fun new project, what do you need? A good project name. Handily, this already exists. There's an NPM library for it, so I've done basically no work. There's the NPM library. The full code for this skill is also on GitHub. I've pulled out code samples to try and fit on the slide and show you, but if you want to see it in context, all on GitHub. And then this is how we invoke it. I will say her name, ask her for the skill, and say what I want the skill to do. She's making me a little bit nervous, so I'm just like filling for time before I have to get her to actually demo this successfully. Alexa, tell me a joke.
Why is the Easter Bunny so lucky? He's got 2 rabbit's feet.
That is fabulous, thank you. It didn't really help the nerves. Let's look at some code. So here's an abbreviated version of the code with some white space crime to try and get it on the stage in such a way you might be able to read it. If not, the slides are online. So all we do is we bring in the project codename generator, generate a random word, 2 random words, and then we return this response that the Echo framework expects. So that should end session means the conversation's finished. I say something, she says something, we're done. There's lots more that you can do, which is like, now ask this, now ask that, right? I'm going to ask her for a project code name, she's going to give me one, we're finished. And then you can send this output speech. I've got type plain text. I've forgotten what the other type is called, but you can teach her to do like expression and inflection. To me, that seems like presentation logic, and I'm a back-end dev, so I've just stuck it out in plain text. You probably work with people like this, I'm sorry. So she just says the project name and a full stop, and then the name. To invoke this from the command line, I would just use action invoke with blocking, or I can ask her to do it. Alexa, Ask project code name for a new project name.
Project code name, Flagrant Star.
Okay. So I taught my skill to do one more thing, and it's to integrate with Redis so she can remember what she just said. You can call your team over and ask her to repeat it so you can all adopt the new code name. So what happens is when we generate that code name, we also store it to Redis. I've got an example just to kind of give you an idea of what it looks like to work with a database or a third-party API. I'm using the standard Redis client for Node. It's not async by itself, so I've got Bluebird in here to make it async. And all that happens is my client.set becomes client.setAsync, and I'm passing a key and a value. So once it's done, once we've generated the name, it saves it to Redis, and then all I need to do is, Alexa, ask project code name to say that again.
Flagrant Star.
There we go. So what we've got here is just something simple, but hopefully that's planting seeds of ideas for you. From within your serverless framework code, you can do whatever you like. You can connect your databases or the cache like Redis that I used here. You can make API calls. You can trigger other serverless actions and make some quite complex stuff. I'm building a fun app with Stack Overflow data that passes around and notifies a Hubot and stuff. And serverless fits really, really well there. I do think this is a revolution. Oh, pressed all the buttons. I do think this is a revolution. I think it's happening now because it could not have happened before. And I really think that as JavaScript developers, you are at the forefront of this. You have the skills required not just for the code, but for understanding how all the different systems go together. It's not, everybody is using like JSON as a data format, and JavaScript itself is such a natural use for all sorts of processing and forwarding. I'm going to leave you with just a few resources. Like I say, the slides are online, so don't worry too much about grabbing these now. The GitHub project is there, the serverless framework that I mentioned. IBM Cloud Functions, check that out. It's a really good way to learn, and because it's based on an open source project, it's easy to have dev platforms to match. And I'm also blogging and speaking a bunch about this, so you can check out my blog as well. I'm not taking questions on stage, but you can come and find me in the igloo in the break, and I would love to chat there or through the rest of the day about this. Thanks for your attention.